discussed all the methods and all the formulas, not methods, but the formulas by shortcut method, isn't it? So let us solve the combined examples on those those formulas. Write down first example, solve. Everyone, please do write this. Solve. D square plus 2D plus 1 times y equals to 2 cos x plus 3x plus 2 plus 3 e to the power x. So start everyone. Everyone will have to put your complementary function in the chat box. Everyone. Hmm? What are the roots here? We can easily see the roots here. The roots are, by considering the auxiliary equation, d square plus 2d plus 1 equal to 0. What are the roots? This is the expansion of d plus 1 the whole square. So the roots are minus 1 minus 1. So everyone drop your complementary function in chat box. What will be the complementary function for the roots minus 1 minus 1? Darshan, write the complementary function for these roots. Gaurav, check this once. Is it correct?
Yes, it's e raised to minus x.
That must be e raised to minus x. Very good. ओके, सबको रिप्लाई करना है क्योंकि मैं चैट बॉक्स सेव करता हूँ. ठीक है. Those who are not replying, that will create a problem for them. Anyways, whatever, मैं ऐसा नहीं कि सही ही रिप्लाई करना है. Whatever you are getting, just I want to check whether you are doing or not. Kshitij, it must be e raised to minus x. Minus x is not there. Yes. ओके, तब तक मैं आगे चलता हूँ. बाकी के सब लोगों ने रिप्लाई करना है चैट बॉक्स में. नाउ टू फाइंड पर्टिकुलर इंटीग्रल पी आई, what we do? We write the formula first. Pi equals to 1 upon phi of d f of x, isn't it? So we first substitute phi of d here. Phi of d is d square plus 2d plus 1, and the f of x given to be 2 cos x plus 3x plus 2 plus 3 e to the power plus x. Let us split this operator over each of these function. So pi will be equals to 1 upon d square plus 1, d square plus 2d plus 1 operated on 2 cos x plus 1 upon d square plus 2d plus 1 operated on 3x plus 1 upon, okay, in fact I can treat this 3x plus 2 as a polynomial, right? Yes or no? Is it a polynomial 3x plus 2? Or even I can separately consider 3x and separately consider 2. That is also one and the same. Plus 1 upon d square plus 2d plus 1 operated on 3 e raised to x. Is this step clear to everyone? सबको clear है? Hmm? I have divided the whole f of x into 3 sub functions. 1, 2 and 3. आप ऐसे भी कर सकते हो, इसको 1, ये 2, this is 3 and this is 4. So in that case you'll have to do the 4 times calculation. Here it will reduce. Is it clear to everyone?
Yes, sir.
Okay. So let us now, we have the shortcuts for each of these sub functions. You can see we have a shortcut for cos, we have a shortcut for polynomial function, we have a shortcut for exponential function. Yes or no? So we use those shortcuts here. How do we get shortcut for cos? What is the rule for cos?
D square replaced by minus a square.
Exactly. We replace d square by minus a square. What is a here? A is 1, isn't it? So we replace d square by that minus 1. So 1 upon minus 1 ka square is minus 1. I mean minus times 1 square, that is minus 1, plus 2d plus 1. And that is operated on 2 cos x plus. What we do for this polynomial function? पॉलिनोमियल फंक्शन के लिए क्या करते हैं हम? पॉलिनोमियल फंक्शन के लिए हम 1 अपॉन 5 ऑफ डी को एक्सपांड करते हैं यूजिंग द एक्सपांशंस 1 अपॉन 1 प्लस पी और 1 अपॉन 1 माइनस पी. तो यहाँ ये 5 ऑफ डी किस फॉर्म में है? दैट इज ऑफ द फॉर्म 1 अपॉन 1 प्लस पी. यस और नो? है ना?
Yes, sir.
So we expand. What is the expansion of 1 upon 1 plus p? It is 1 minus p plus p square minus p cube. अगर डिनोमिनेटर में 1 प्लस p है तो हमें अल्टरनेट प्लस माइनस साइन देने हैं. एंड अगर डिनोमिनेटर में 1 माइनस p है देन ऑल द टर्म्स विल बी पॉजिटिव इन द एक्सपांशन. So 1 minus p, what is p here? d square plus 2d plus p square, d square plus 2d का square plus and so on, isn't it? And that is operated on 3x plus 2. Now for this third, what we do for exponential function? We replace d by we replace d by 1, d by a, na? In case of
Yes, sir.
exponential function we are replacing d
D
by
by
a,
a.
where a is 1. You can see here a is 1 e raised to ax में. So what it will be then? 1 upon 1 plus 2 plus 1 3 e raised to x. So simplify it now. This minus 1 plus 1 get cancel. The next is 1 upon 2 into 1 upon d. क्या होता है? 1 upon d is integration of 2 cos 2x. Yes or no? See, 1 upon 2d के लिए लिख रहा हूं मैं, है ना? 1 upon 2d का 1 by 2 तो मैंने ऐसे लिखा, and then 1 upon d means integration. Clear to everyone? Plus. Now for this infinite expansion, how many terms we need to consider from this, or which are the terms we have to consider, or we have to write here? Those which are non-zero powers of d. So जितनी पॉलिनोमियल की डिग्री होगी उस पावर तक हमें डी के टर्म्स कंसीडर करने. सो व्हाट इज द डिग्री ऑफ दिस पॉलिनोमियल हियर? पॉलिनोमियल की डिग्री है, यस,
1.
The degree of polynomial is 1. So we consider the powers of d up to 1 only. So what are those terms? This is neglected. This is considered. D square the whole square is neglected. इसमें कोई term है जो d in terms of d होगी इसके expansion में? No ना? So the whole term will be neglected. Even the further all terms will be neglected. So only we need to consider 1 minus 2d, that is operated on 3x plus 2, plus what this will be, 3 by 4 e to the power x. Sorry. ठीक है, यहां तक क्लियर सबको? So this 2 will get
Yes, sir.
cancelled. Integration of cos is minus sine 2x upon 2. Sorry, integration of cos is plus sine 2x upon 2, isn't it? And plus 1 into 3x plus 2 minus 2 into d of 3x plus 2 plus 3 by 4 e to the power x. That is equal to sine of 2x upon 2 plus 3x plus 2 plus 2 into, what is derivative of 3x plus 2? It is
3.
3. Yes, so 2 3s are 6, right? Plus 3 by 4 e to the power x. You can see d is completely gets eliminated, isn't it? And that is our required particular integral. Clear to everyone? Come on, everyone, please do reply in chat box whether it is clear or not. Therefore, the general solution is y equal to cf plus pi. So you have to write cf here, that is c1x plus c2 or c1 plus c2x e raised to minus x plus this pi sine 2x upon 2 plus 3x plus 2 plus 6 plus 3 by 4 e to the power x. Is this clear to everyone? सबको reply करना है chat box में. Only 2 people have replied, Rohit and Shruti. बाकी के लोगों को कुछ किसी को प्रॉब्लम है तो पूछ लो. You can see the whole solution and then you can ask if any doubt. अगर आप 3x को and 2 को separate भी करते हो then also you'll get the same answer, don't worry.
सर cos 2x का डाउट है.
हाँ, yes. अच्छा, it is cos ना, just it is just cos actually,
Yes sir.
right? It is just cos. By mistakenly I have considered cos 2x. Sorry for this. It's not doubt, it's my mistake. Right? Is it okay now?
Yes sir.
I'm sorry for this. A sin x also, that will be just sin x here. Yes. Okay, so if no doubt, then start with the next. Second, solve d minus 1 the whole square into d square plus 1, the bracket square, times y is equal to sine square x by 2. Chalo. Fast. What are the roots of his auxiliary equation? अभी यहीं से हम रूट पता कर सकते हैं क्योंकि द गिवन फाई ऑफ डी इन टर्म्स ऑफ इट्स फैक्टर्स, सो इमीडिएटली विल गेट, है ना, बाय इंस्पेक्शन ओनली यू कैन टेल मी द रूट्स, दैट इज सबको रूट्स लिखने हैं चैट बॉक्स में। व्हाट आर द रूट्स? नो, गायत्री प्लीज चेक इट वंस। Gayatri, check your roots again. First of all, how many roots it will have? 6 roots. ठीक है। Darshan, 6 roots it will have. Darshan Nerkar. You just check it once, Gayatri and Darshan. बाकी के लोग क्या कर रहे हैं? सो रहे हैं क्या? हाँ, अगर फाइव डी फैक्टर्ड फॉर्म में नहीं होता तो थोड़ा सा डिफिकल्ट होता, लेकिन इट इज इन फैक्टर्ड फॉर्म, यू जस्ट नीड टू इक्वेट दोस फैक्टर्स टू जीरो। वेरी गुड दर्शन, वेरी गुड प्राची, yes, Ishwari, you're right. So write the complementary function with these roots. Those who have replied, सबको रिप्लाई करना है। Yes. Yes. See, those who are doing honestly, definitely that will be beneficial for them. Those who are just copying and typing into the chat box, remember. Hmm? Very good. Everyone. ठीक है। So सबको रिप्लाई करना है, तब तक मैं आगे चलता हूँ। So write with these roots the complementary function d equals to 1 repeated twice। इसके लिए see here, d square plus 1 के repeat roots है plus minus I, and that is repeated 2 times, you can see here। So plus minus I plus minus I, so how many roots in total? We have 6 roots. So we write the complementary function which will be having 6 arbitrary constants, so be careful about while writing the complementary function. So for 1 I'm writing c1x plus c2 e to the power x, plus for these repeated complex roots alpha is 0, isn't it, and beta is 1, so e raised to 0x will be 1 only, and I'm writing directly into the bracket c3x plus c4 because roots are complex repeated, cos beta x, where beta is 1, plus c5x plus c6 sin x। क्लियर टू एवरीवन? सबको क्लियर है? अरे कोई तो रिप्लाई करो।
Yes, sir.
हम्म, आपके लिए ना सही, मेरे लिए तो रिप्लाई करो। 1/phi ऑफ डी पी आई का फॉर्मूला क्या है? 1/phi ऑफ डी एफ ऑफ एक्स। सो द phi ऑफ डी हियर गिवन टू बी d minus 1 the whole square, d square plus 1 the whole square, and that is operated on sine square of x by 2. So do we have the case for sine square x? We don't have. right? We have a case for linear sine and linear cos. So what we do, we can convert this sine, we can reduce this sine square into linear powers. We have the formula sine square theta क्या होता है? I have given you the formulas also. Sine square theta is
1
1
minus cos 2
cos
x
2
cos 2 theta
theta.
upon
Yes,
2.
cos 2 theta upon 2, where theta is x by 2, isn't it? So cos 2 into x by 2, the whole upon 2. Very good. Thank you. Who's that?
Gayatri.
Gayatri. Okay. So that is equals to पहले तो this 2 will get cancelled from the cos, isn't it? This will getting cancelled here. So it is just cos x. So when I split the denominator to these two, so I'll be getting 1 by 2 and then cos x by 2. So I'm splitting this 1 upon 5 of d, I'm dividing this 1 upon 5 of d to both of these terms. So 1 upon d minus 1 the whole square into d square plus 1 the whole square into 1 by 2 minus 1 upon d minus 1 the whole square into uh, what d square plus 1 the whole square operated on cos of x by 2. ठीक है? Now what the rule for constant term? We have shortcut for constant. What we do? We replace d by 0. If you remember, we have discussed the case in exponential function sub case. If the function is constant, we replace d by 0 there. So 0 minus 1 square, 0 plus 1 square into half minus, इसके लिए क्या करते हैं हम? For cos we used to replace d square by minus
Minus a square.
a square, where a is 1. So that 1 by 2 cos x by 2 na, so 1 by 2 I'm writing here suppose, and then 1 upon, first of all let us expand this. So d square minus 2d plus 1, and here the expansion is d square square minus 2d plus 2d square plus 1 times cos. So let us replace this d square by minus 1 wherever we have. So therefore इसका क्या होगा? 1 into 1, right? Minus 1 का square is 1, 1 का square is 1, so that is just half. Minus half into क्या होगा यहाँ? This is minus 1 minus 2d plus 1 into minus 1 का square 1 plus 2d square, but d square is minus 1, so that will be minus 2 and plus 1. Please check whether my calculations are correct or not. Okay, everyone. Is it correct up to this? Minus 1 का square is 1 plus 2d square, but d square is minus 1, so that is why it is minus 2 and plus 1. I hope it is correct. Minus 1 by 2 into 1 upon, ये इसका क्या होगा? 1 minus 2 plus 1, so that will be 0 na. This is the case of failure na, 1 plus 1. Is it the case of failure?
Yes, sir.
So for case of failure, what we are doing?
Differentiating.
Yes, we're differentiating the denominator. Just a minute. Huh? So what we do, we have to differentiate this, but when we differentiate, Just a minute. This will be the case of failure. So for a while, let us keep this factor as it is. First, we do the calculations for this factor, and then we will do the case for the next, because that is the case of failure. So d square plus 1 as it is, let it be. Because if you replace d square by minus 1, that will be a case of failure. ठीक है, तो पहले इसके लिए करते हैं. हाँ, 1 minus 1 plus 1 will get cancelled, and that will be minus 1 by 2d. So minus minus plus 1 by 2 into e 1 by 2, that I'm writing here 1 by 4, and 1 upon d times 1 upon d times cos x, right? 1 upon d square is also there. Cos x. So what we'll do, 1 upon d means what? Integration. So 1 by 2 plus 1 by 4, 1 upon d square plus 1 integration of cos x dx. So what is integration of cos x? Hello? Integration of cos x is sin x. And now we proceed with this 1 upon phi of d sin x. So as we know, when we replace d square by minus a square minus 1, that will be a case of failure. So what we are doing exactly in case of failure? We are differentiating the denominator and we are multiplying the whole operator by independent variable x into 1 upon phi dash. तो क्या है इसका डेरिवेटिव? 2d ना, sin x. Yes or no? So that is equal to 1 by 2 plus x by 8, because this 4 2s are 8, and 1 upon d means integration of sin x dx. Is it okay?
Yes, sir.
So x by 2 integration of sin x is minus cos x. So 1 half minus x by 8 cos x. Is there something wrong in the calculations? Everyone, please do check. Because I have different answer. Am I doing something wrong in the calculations? We have the sine square x by 2, right?
Sure, it's d square plus 1 whole square.
Huh. So, oh, sorry. Here it must be square. Square. Yes. Very good. Square there. तो यहाँ से मुझे so what will be the derivative of this? इसके लिए हमारे पास एक फॉर्मूला था, हमने देखा था डी स्क्वायर प्लस ए स्क्वायर रेस टू आर, इफ यू रिमेंबर. यस, क्या था फॉर्मूला वो? सी, इफ, लेट मी राइट द फॉर्मूला हियर, 1 अपॉन डी स्क्वायर प्लस ए स्क्वायर रेस टू आर साइन ए एक्स, where when we replace d square by minus a square, that will be a case of failure how many times? R times, isn't it? So we have the formula for this. It will be minus x upon 2a raised to r 1 upon r factorial sine of ax plus r pi by 2. This is the formula अगर r times case of failure है तो, and the same formula for the cos. ठीक है, so we use that formula here. 1 upon d square plus a square raised to r. What is r here? R is 2. Yes or no? So x square by 2 factorial, sorry, x square by, sorry, it's not x square. It is minus x upon 2a. What is a? A is 1 raised to 2 into 1 upon 2 factorial sine of x plus r. What is r? R is 2. So 2 pi by 2 means pi. Right? Is it correct or not? Hello? Everyone please do reply. कोई तो reply करो.
Yes,
यहाँ
sir.
तक clear है?
Yes, sir.
Now it will be correct. Let's check it now. ये 1/4 तो correct है ना? हाँ, yes, 1/4 is there. तो क्या होगा ये? माइनस एक्स स्क्वायर विल बी प्लस एक्स स्क्वायर अपॉन 2 का स्क्वायर विल बी 4. सो 4 4 जा 16 2 जा 32 एक्स स्क्वायर बाय 32. राइट. एंड साइन ऑफ पाई, पाई प्लस थीटा क्या होता है? साइन पाई प्लस थीटा
माइनस थीटा.
माइनस साइन थीटा ना? राइट.
Yes, sir.
Sin pi plus theta will be minus sin theta, where theta is x. ठीक है? So this will be your particular integral. That is correct now. This is what the answer I am having. But is it clear to everyone? Each of this step. देख लो एक बार. I forgot to write the power 2. But it is okay now. So with this, we write the complementary function CF plus PI. We have to write, okay? Write the complementary function and the particular integral. That will be your general solution. I hope it is clear now. Yes, everyone? Reply
Yes,
everyone in the chat box. Okay, okay, fine. Everyone, सबको reply करना है chat box में. Solve d raised to 4 minus 1 times y is equal to cos x into hyperbolic cos x. Very good. Cos x into hyperbolic cos x. So what is the complementary function first? Here the auxiliary equation is d raised to 4 minus 1. See, most of the times in exam also you'll be given phi of d in terms of its factor form, either in factored form or in capital D form. Isn't it? Because examiner don't want to waste your time also. He just want to check the concepts. So he will give either in capital D form or in factored form so that you can directly get the roots. अगर स्मॉल डी फॉर्म में भी है तो वो भी इजी रहेगा. ठीक है. सो व्हाट आर द रूट्स हियर एवरीवन? पहले तो इसको मैं कैसे लिख सकता हूं? डी स्क्वायर द होल स्क्वायर माइनस 1 स्क्वायर. सो बाय यूजिंग फॉर्मूला ए स्क्वायर माइनस बी स्क्वायर, क्या होता है वो? डी स्क्वायर माइनस 1, दैट इज ए माइनस बी इंटू ए प्लस बी. यस और नो?
Yes, sir.
So with this factor, d square minus 1 के roots क्या है? d equal to plus minus 1. Isn't it? And for this factor, the roots are d equal to plus minus I.
I.
Right, so these are the four roots. So write the complementary function for these four roots. Cf is equal to c1 e to the power x minus x plus c2 e raised to x plus for the complex roots c e raised to 0x will be 1, c3 cos x plus c4 sin x. Right, this is the particular integral. Sorry, this is the complementary function. Now particular integral is 1 upon phi of d f of x. Always have a habit to write the formula so that the next step is clear. So 1 upon phi of d. Phi of d is d raised to 4 minus 1 and fx is cos x into hyperbolic cos x. So do we have any reduction formula for the product of normal cos and hyperbolic cos? I think no, right? We don't have any formula. So what we can do, we can have a formula for hyperbolic cos x in terms of normal exponential functions. That is here it is d raised to 4 minus 1 cos x into, I can write for hyperbolic cos x e to the power theta, that is x, plus e to the power minus theta upon 2. Yes or no? This is the formula for hyperbolic cos. And now when I multiply by taking this 1 by 2 outside the operator directly, and when I multiply by cos inside, I'll be getting the functions like this: d raised to 4 minus 1 e raised to x cos x plus 1 upon d raised to 4 minus 1 e raised to minus x cos x. Is this step clear? Everyone, please do reply. Is this step clear?
Yes, sir.
Now, which subcase of shortcut method to be used here for both of these? We can use the case number 5, I guess, e raised to ax into v, if you remember. What that case says, e raised to ax into v, we have seen in the last, yesterday, case number 5. Yes, this one. What that case says, we write the exponential function outside the operator and immediately we replace d by d plus a there. Clear to everyone? So we use that case. We write exponential function outside the operator, and when we write, we replace this d square d. Kya? When we replace d by d plus a. What is a? A is 1. इसका a है, दोनों का actually दोनों का a same ही है, e raised to ax and cos ax, but that is not all the time, remember. So हमें exponential का a consider करना है. So that a is 1. So I replace this d by d plus 1 raised to 4 minus 1. ठीक है, operated on cos x plus, here also the same thing, I'm writing exponential function outside the operator, that is e raised to minus x. This red ink denote the changes, okay. D will be replaced by d plus a, but a is minus 1, so d minus 1 raised to 4 minus 1, that is operated on cos x. Is this step clear to everyone by using the case number 5? Everyone reply chat box. सबको clear है यहाँ तक? Now we have to expand these two, d plus 1 the whole raised to 4 and d minus 1 raised to 4. So आपको शायद अगर पास्कल ट्रायंगल पता होगा तो उससे आप इमीडिएटली एक्सपांड कर सकते हो. And the expansion is d raised to 4. We start with the highest power of d. And alternate प्लस के लिए सब पॉजिटिव टर्म है, माइनस के लिए अल्टरनेट प्लस माइनस. सो प्लस 4d क्यूब प्लस 6d सॉरी क्यूब d स्क्वायर प्लस 4d प्लस 1. And the same term with alternate plus minus sign are there. So d raised to 4 minus 4d cube plus 6d square minus 4d plus 1. These are the expansions. We need to substitute these expansions here. So what we get then? Therefore, pi equals to half e raised to x into 1 upon d raised to 4 plus 4d cube plus 6d square plus 4d plus 1 and minus 1. ये लास्ट वाला minus 1 cos x plus e raised to minus x times d raised to 4 minus 4d cube plus 6d square minus 4d plus 1 and ये लास्ट वाला minus 1 cos x. ठीक है. Now we use the case of cos. What the cos says? Cos says replace d square by minus a square, where a is 1 here. So plus half e raised to x into 1 upon जहां जहां डी स्क्वायर होगा वहां हमें -1 सब्स्टिट्यूट करना है. सो डी रेज टू 4 मीन्स डी स्क्वायर स्क्वायर. सो -1 का स्क्वायर हो जाएगा वो, प्लस 4 डी क्यूब मीन्स d into d square. So d into -1 I'm writing. I hope I'm skipping one step here. If you have a doubt with this step, please let me know. 6 into -1 plus 4d. A -1 plus 1 gets cancelled, cos x. And plus for this e raised to minus x into 1 upon -1 square, because d raised to 4 is minus d square square. Are you getting my point? D square square. So I'm replacing d square by -1. So that is why it is -1 square here. Please check. ठीक है. Minus 4d into d square, but d square is -1. Plus 6d square, but d square is -1. Minus 4d plus 1 -1 gets cancelled, cos x. Is this clear? यहां तक सबको clear है?
Yes, sir.
So I request everyone, can you do further? Can you do the steps further? आप यहां से आगे solve कर सकते हो? You just need to simplify, and if still d is there in the denominator, to get d square in the denominator, rationalize it. Remember, don't involve this exponential function inside now. इसका काम हो गया. इसका काम था d को रिप्लेस करना d स्क्वायर से. अभी इसको बाहर ही रखो. क्लियर टू एवरीवन? तो आगे सब लोग कैलकुलेशंस करो. आई एम गोइंग टू स्टॉप हियर बिकॉज इट्स टाइम. ऑलरेडी वी हैव क्रॉस टाइम. So if d is there in both of those terms, d will be there in the denominator. So to get d square, rationalize the denominator. You'll get d square and replace it. That will be a final particular integral. Everyone, will it be okay?
Yes, sir.